on 9.3. We have pipe A and pipe B. And then, was it 35? Together, right, is the third thing. And then it's, what is it, time to fill? So together, how long does it take it to fill? 2 hours, yep. One of the pipes used alone takes 3 hours longer than the other. So if pipe A takes T hours to fill, what does pipe B take? T plus 3, okay? So this is job done in 1 hour. How much of the job is going to be done in 1 hour if together they can do it in 2 hours? How much of the job is done in 1 hour if together they can do it in 2 hours? A half. For A here, right here, if you can do the job in T hours, how much do you do in 1 hour?
1 over T.
1 over T, correct. And then what about this space right there? What's that going to be? 1 over T plus 3, exactly. So you know that pipe A can do 1 over T in an hour, pipe B can do 1 over T plus 3 in an hour, and pipe 3 can do a half of the job in an hour. So what equation can we write?
Is it 1?
Oh, wow.
Or 1 over T plus
Yep.
over T plus 3
Equals?
2.
No.
Oh,
You can only add together columns. You can only add together the same thing. So now we have the equation we can solve. Now what should we multiply this by in order to just do this the quickest way possible?
T times T plus 3 times 2.
Yes, times 2, exactly. So if we do that, what do we end up with? T plus 3 times 2 plus T times 2 equals what?
T times T plus 3.
T times T plus 3. Is that a quadratic? Yep. Is that in standard form? No. This one's relatively straightforward because you end up with 2t plus 6 plus 2t equals t squared plus 3t. Is it in standard form yet? What? Why not? Why isn't it equal to standard form?
Because they're not all on one side.
And yeah, they're not grouped together, right? So it's going to be t squared minus how many t's?
1.
Minus a t, yep. And then what, minus 6? And you always ask yourself at this point, what method should you try first? And can you factor it? Yeah. Yep, what is it?
2t minus 3t plus 2.
Yes, and that equals 0. So t minus 3 equals 0, or what?
T plus 0.
Equals 0. So what does t equal here? T equals 3, or what? So which one does it have to be?
3.
Because
It's time.
it's time. So it's t equals 3. So the first person do it in 3 hours, and the other pipe can do it in 6. There it is. Together they can do it in 2. Excellent. Is that in standard form? No. What do we need to do to put it in standard form? Yeah, so you have at squared plus bt plus c is equal to 0. And then you're not going to factor. What method are you going to use? Yeah, in this case, little a is equal to a, b is equal to b, and c is equal to c. So in this case, what is the discriminant equal to? Capital B squared, exactly, for AC. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And is the capitalization important on this one? Yeah. Yeah, it's different.
So you don't do anything.
There's nothing else to do.
Okay.
Tell me what it is. H is equal to L plus 2. The hypotenuse is 2 inches longer than the longer leg. Write that down. Good. The longer leg is 1 inch less than twice as long as the shorter leg. So what does L equal? 2s minus what? 1. Exactly. Exactly. Now it says, now we want to find how long is each side of the game board. So what type of triangle is this? It's a right triangle. So what do we know is the relationship between these three variables? L squared plus is equal to h squared. Right? But here's the thing. We need to go down to one variable, so we need to do some substitutions. What does h equal? So we know L squared plus S squared is equal to L plus 2 squared. How many variables do we have now? We had 3 right here on the first one. We had 3 in this one, and now we have 2. We want to get down to 1 so we can solve it, right? Which equation have we not used yet? This one. We haven't used this one yet. But if we let L equal S, we're going to still be 2. So what should I solve for in that red one? What should I solve for? So what do we know here? We know that 2s minus 1 is equal to L. So 2s is equal to what? So s is equal to? So we take that and we plug it in. Where do we plug it in? S. So what do we end up with? We end up with L squared plus L plus 1 over 2 squared equals what? L plus 2 squared. Is that a quadratic?
No.
Yes, it is. It is a quadratic. Is it written in standard form? No. Do this for me. Write this in standard form right now. Clean that up and write it in standard form right now. So if you do out the other side, what do you end up with? L squared plus 4L plus 4. So you end up over here with, you do it out, L squared plus what? L squared plus 2L plus 1 all over 4 equals L squared plus 4L plus 4, like this. Now you could, if you wanted to, this is what I would do at this point if I was going to write this in standard form. Do you guys really, really like to stay with fractions if you can? No. So what could I multiply everything by? So if you do that, you end up with what? 4L squared plus L squared plus 2L plus 1 equals 4L squared plus, I can almost multiply, almost, it's not 8, what is it? 16L plus, now we just have to combine some things.
Are you multiplying by a 4 over 1?
I'm multiplying by 4, which is the same thing as 4 over 1. I'm multiplying everything by 4.
Because I tried that and then...
Okay, just follow this and see what happens. So, what do we end up with? What cancels on both sides?
4L squared.
Yeah, the 4L squareds cancel. That's kind of nice, right? So, we're left with L squared plus 2L plus 1 is equal to 16L plus what? Is that in standard form?
No.
No. So it's going to be L squared plus how many L's? Minus how many of them? 14L minus 15 equals 0. Ah, and then you ask yourself, is this factorable? It's going to be L and L. Yeah, it's going to be what? Minus 15 and plus what? Like that? So L minus 15 equals 0, or what? L plus 1 is equal to 0. So what does L equal? 15 or L. Now which one does it have to be? Why? It's dealing with a length, exactly, right. So you go back up here and you say, okay, so if L, so we now know that L is 15. So how do we get H? What's the relationship? So it's going to be 17, and then and then you know S. You see S. We already solved for it right over here. S is equal to L plus 1 over 2. Well, if L is 15, what's 15 plus 1? 16 divided by 2? 8. There you go. 8, 15, 17.
Can you go back down?
Nope, because it's synced with... Is it in standard form?
No.
I've asked you that hundreds of times, so you should automatically think to yourself if you're solving a quadratic, is it in standard form? No. So what should you do to put it in standard form? What should you do? Subtract Q. Standard form is ax squared plus bx plus c, right? Equals 0. So we're solving for t. So what's the thing in front of t squared? Yep. What's the thing in front of t? And what's left? Negative q. So if you want to find the discriminant, remember, what is the discriminant? b squared minus 4ac. So that's v squared minus 4 times 1/2 g times what? What's a negative times a negative? So you end up with v squared plus 2gq. Because what's 4 times 1/2? 2. So that's your discriminant. So x is equal to negative b. What was b again? V. So it's negative v plus or minus the square root of this all over 2 times a. What is a? 1/2 g. There's only one thing you can do to simplify this. What's 2 times 1/2? 1. So you get negative v plus or minus the square root of this. Can you simplify that at all? No. Say no. What's the thing inside the square root that makes it so you can't simplify that? The plus sign. Please don't do anything. You are done at this point right here. You are done, you are done, you are done, you are done. There's nothing you can do. Stop there. You're done. Got it? Yes, Liv. That's a quadratic. This is a quadratic. Do you remember what the graph is called? What's that shape called? It's a parabola. It's a parabola. Parabola. What's a parabola look like? What shape?
Giant U.
Looks like the giant U, exactly, right there. There are some important features of a parabola. Can someone tell me one important feature of a parabola? Yes, Jen.
Like, if you cut it down the middle, like.
Yeah. Oh, so you're saying cutting it down the middle like this? Yes. So if we cut it down the middle, say we labeled that point right there. What's that point called? Anybody know?
Vertex?
Yeah. This is called the vertex. Parabolas can face up or down. Up or down. If A is positive, it faces up. If A is negative, it faces down. The vertex is either the highest or the lowest point. Can a vertex have a highest and a lowest point? No, because this one, does this have a highest point? No, it keeps on going forever, right? If it flips upside down, does it have a highest point? Yeah, the vertex becomes the highest point. What can you tell me about this? This thing is called, what do they call it? They call it different things in different books. I think they call this the axis here. Yeah, the axis. I like calling it the axis of symmetry. Why is it called the axis of symmetry?
Both sides are equal.
Yeah, if you folded it over across that line, they would overlap completely. So the vertex is the lowest point or highest, and the axis of symmetry is that vertical line that goes down the middle. Remember, this is always going to be vertical. So how do you go about graphing these things? How do you go about graphing them? Well, let's say I gave you this, y equals some function ax squared plus bx plus c, and I said it looked like this. Let's just say it looked like this. Yay! So there's your function right here. So let's just say I gave you the picture of that function. What would happen, do you think? What do you think would happen if I did the same function, but I added 2 to it? What do you think would happen if I added 2? So this is this function right here. What do you think would happen to the graph of the function if I added 2 to the outside? Nick?
Would it become like more straight?
Nope. Good guess. Good guess, Maria.
The vertex would go up to.
So what would happen to all the other points? They would all go up 2. So the whole thing goes up 2. So if you add or subtract a number on the outside, it either goes up or down.
On the y-axis.
On the y-axis, up or down. Up or down is always going to be the y-axis. Exactly right. So if I change this, this would be, it would move up 2. It would move up 2 from wherever it was. Does that make sense?
Yeah.
So what happens if I subtracted 2? The whole thing would go down 2. So if you want to go up or down, you add something or subtract it to the outside. The outside. So the other way you can move it, so let's say I gave you this. Y is equal to some parabola. Here it is, right here. Oh, I don't actually need to draw that in. So let's just say I drew it in like this. Right, I'll draw it in this color right here. So let's say you had this parabola right here. There it is. What do you think happens, and be careful, if I instead added something to the inside? So let's say I added 2 to the x value. Instead of adding it on the outside, I added it to the x. So what I mean by that is we might have y equals, let's say, ax squared plus bx plus c. And instead of adding 2 to the outside, I added it to the x value directly, like this. What do you think is going to happen? Anybody want to raise their hand and guess really carefully what they think is going to happen? Jen, what do you think?
To the right.
Do you think it goes to the... So it's going to go... I will give you that. It goes side to side. It's not going up or down anymore.
No, it goes to the left.
This means...
And then if you subtract.
It's the opposite. This goes left to. So if you have this blue thing right here, and I want to make the new graph green, let's say the new one is green here. Let me get green again. It's going to go left to. So it's going to go like here. What happened? I can draw points really well. It went how many over? 2 to the left. So the only thing you need to remember is if it's on the inside, it goes the opposite direction to what you think. It goes the opposite direction to what you think. So obs, let's say I gave you this function. I said y is equal to g of x, and I told you it's a quadratic. It could be any function. But let's say I said y is now, let's say, I'll give it a different function. Let's say, sure, we can do y, it's fine. Let's say a new one, y is equal to, how about g of x plus 1 minus 4. Can someone tell me, maybe Aubrey, can you tell me, if I wanted to go from this function to the next one, what do you have to do? Does it go up, down, left, or right?
It goes left and down.
It goes, yeah, down how much?
4.
Down 4, and left how much?
1.
Exactly. So if you had the graph of the first one, can you make the graph of the next one really easily? You just move the points. You just move the points. Exactly. So all you're doing right now is you're going to be moving things left, right, up, and down. The base graph, the easiest one you need to remember, and this is as important as y equals x. What does y equal x squared look like? Does anybody know what that looks like? Y equals x squared. Anybody know? Well, when x is 0, what's y? 0. When x is 1, what's y? When x is negative 1, what's y? 1. When x is 2, what's y? 4. And when x is negative 2, what's y? It's going to be symmetric. So what does this look like? It's a parabola at the origin. You say the vertex is at the origin right there. So if I added 2 to the outside and put 1 on the inside, could you move that one around? Yes. So the first type of translation, this is just called shifting. That's all we've been doing. We have the same shape. Both of these things, did these things change the shape of what we were doing? No, it just took the parabola, the same parabola, and what did it do? It went left 2. What did this one do right here? It went down 4 and left 1. Did the shape change? No. Are there things we're going to do later where the shape will change? Yeah, as Nick was talking about, maybe, are we going to go make it wider or shallower? Yes, we are. What's your question, Harry?
I don't know if you can answer this, or
Yep.
does it go the opposite way? Why does it go left?
It goes left. What you can do is if you made a table of values, like if you actually made a table with like x and y and you plugged in values, all of a sudden everything would move left, because essentially you think of it as when you're adding or subtracting on the outside, it's going in at the end after the function runs, but when you put it on the inside, it's going before. So basically, if you add 2, like look, I'll tell you, like right here. So like plus 2 right here. Why does this go left 2?
Yeah, only
Because look, if the original function is f of x, right? Plugging in 4 here would be the same as plugging in 2 now, right? Plugging in 2, what's 2 plus 2? 4, right? Plugging in 2 here is the same thing as plugging in 4 if that 2 wasn't there. So plugging in 2 behaves like 4. Plugging in 3 behaves like 5. Plugging in 4 behaves like 6. Plugging in 7 behaves like 9. So what are you effectively doing? You're moving a 2 to the left. This is happening before the function runs. This is happening if you have it on the outside after the function runs. That's why. But just remember, inside, opposite direction. You think of up and down as positive and negative, right? You think of positive and negative as right and left. When it's inside, it's going to go the opposite direction. So, for example, I could give you, if I said by hand, if I said don't do this, let's say I said by hand, if I said capital F of x, remember that's just the name of the function. I could call it Bob if I wanted to. F of x is equal to, let's say, x plus 3 squared minus 2. You would start with the graph of y equals x squared. So you start with the graph of y equals x squared. It looks like this nice parabola, right? And then what would you do to it? You'd move it, go down 2. So let's go down 2. So if I go down 2, what's that new function going to be? It shouldn't be wider, right? Remember I said it doesn't change the shape? So don't make it wider like I just did. So it's going to go up like this, right? It will intersect. But if I just move it down 2, what is it? It's y equals x squared minus 2. But what else do I need to do? Move it to the left 3. So I go over to the left. So this graph right here, what's this one right there? Y equals 3 squared minus 2. Because what have we done, everybody? We have gone,
To the left 3.
we went down. How much did we go down?
2.
We went down 2. And then what did we do? We went to the left, how much? 3. And now we have the graph. So what you can do is you can graph these by translation. You have translated it. When you translate something, the shape doesn't change. What do you think is coming in the next part of this, or the next section of this? How do you change the shape of it? How do you change the shape of it? So right now, if you shift it, we only have 4 directions. That's pretty nice, right? Up, down, left, and right. That's fine. In terms of changing the shape, you can either make it steeper or you can make it shallower. Let's just say steeper and shallower just to make it easy to deal with, right? Let's see if you can guess the translations. Let's see if you can guess the translations. So let's say you had, let's say f of x is equal to 2 times some quadratic. If you multiply the whole thing by 2, do you think it makes it steeper or shallower? What do you think? It makes it steeper, because what happens to all the y values? No, they get multiplied by 2, because these are the outputs, right? what happens to all the output values? They double. So if you got 2 out before, you still only get 4. If you had 4 out before, you become 8. Okay, what do you think happens here? F of x is equal to 1/2 g of x. Shallower, because if the output was 10, what does the output suddenly become? 5. Shallower by, you can say by 2, but it's the same idea. Shallower means it's getting smaller, right? So what does that mean graphically? Let's say I said you had the function y equals 1/2 x squared. You start by graphing y equals x squared. And do you have a general idea what that looks like? Yeah, it looks like this, right? So if that's y equals x squared, approximately what does y equal 1/2 x squared look like?
Like halfway.
Yeah, it's going to kind of look like this.
Oh, well, I thought it gets
Shallower, shallower. That means shallower. So what about this one? That's y equals 1/2 x squared. What happens if I gave you this one right here? What happens if I said y equals 2x squared? What's going to happen there? It's going to be steeper like this. It's going to be twice as steep like that. It's still curved. So if you multiply by something greater than 1, what happens? It gets steeper. If you multiply by something between 0 and 1, it gets shallower. What happens if I put a negative on the outside? Only one thing happens.
Wait.
It flips. It flips. Yeah, go ahead.
Didn't you just say it got shallower?
No, sorry. This means steeper. This means shallower. This
You
means
just
steeper.
know-
It's like
you just
it's touching like the lower y values. Like if it gets shallower.
Yeah. So think about it this way. Shallower means shallower, like this way, okay? Steeper means steeper, okay? We're not quite, sorry, the clock thing is really messing me up. Okay, so tonight, everybody, tonight you have questions from 9.3, 9.4, and some from 9.5.